everyone. Today we are going to discuss a problem named distribute candies. So let's move to the description part. Here they are saying there are n students standing in a line. Each student is assigned a rating value, and you are responsible to distribute the candies to these students subjected to the following requirements. Each student must have at least one candy because every student deserves it. Okay, so every student would be getting at least one candy. And second rule is students with the strictly higher rating gets more candies than their neighbors. Okay, so then they are asking what is the minimum number of candies you need to distribute to the student. Okay, it can be, I mean, the numbers can be any, okay, any big number, but still they want the minimum candy. Minimum means uh, uh, one candy less than that won't be satisfying these two situations. Okay, so that's why. Now input, the first line of the input contains the number of test cases, which is 2. Okay, and then for each test case, first line contains the number of students, n equals to 3, and then second line of each test case contains the rating of those students. Like first student have rating 1, second have 0, and third have 2. Okay, now let's move to the given parts. Okay, what is given? Again, we need to distribute candies to each student such that both of these rules should be satisfied. What is the rules? First, each student must have at least one candy. Okay, and second is student with strictly higher rating gets more candies than their neighbors. So moving on, let's see with an example. In the input part, one of the given is 3 students and ratings are 1, 0, 2. So 1, 0, and 2, and n equals to 3. Okay, now just to satisfy the rule number 1, each student must have at least one candy, correct? So that's why in the candies array, or you can name it anything, okay? Just put 1, 1, and 1 initially. So rule number 1 have been satisfied, done, correct? Now let's try to satisfy the rule number 2. What is rule number 2? A student with strictly high rating gets more candies than their neighbors. Okay, neighbors. Here is the catch, because when we say neighbors, okay, when we say neighbors, there are two neighbors. Okay, first is left and next is second is right. Okay, so we are going to check for both. Okay, check for both because they have said ratings. Okay, let's see this again. A student with a strictly high rating gets more candies than their neighbors. Okay, so that's why for both neighbors we are going to check. Now let's move and let's call the checking for left neighbor as to A part. Okay, one was done. So one was filled. Now we are checking for the left neighbor. When we're talking about left neighbor, okay, so for the very first item in the array or for the very first student, okay, there is no left neighbor. Okay, so that's why just because we are going to compare for the with the left neighbor, we'll be starting with the second student till the last student. Okay, so that's why second student have rating is 0, and who is the left neighbor? First student is the left neighbor. Okay, this student is the left neighbor. So is 0 strictly greater than 1? Yes or no? No. If 0 is not greater than 1, so what will happen? No changes, correct? No changes in the candies. Now moving on to the next student. This student is the third student. This have the left neighbor, yes, as the second student. Second student is the left neighbor of third student, correct? So rating of third student is 2, and rating of second student is 0. Is 2 greater than 0? Yes, it is. So what would happen if the rating is greater? Okay, then this third student would get one more candy than the second student, correct? So 1 plus 1 would become 2. Okay, so after comparing the left neighbor, the total candies for each student would be looking like this: 1, 1, and 2. Okay, now moving on. Let's check for the right neighbor. Okay, again, when we are saying the right neighbor, then the last student don't have any right neighbor, correct? Don't have any right neighbor, don't have any neighbor. So that's why we will start from the second last student. The second last student would have neighbor as the, I mean, last student as the right neighbor, correct? So rating of second last student is 0, and which is and the last student is 2. So is 0 greater than 2? No. So what will happen? Nothing, no change, correct? So we'll move on to the first student. First student rating is 1, and its right neighbor is second student whose rating is 0. Is 1 strictly greater than 0? Yes, it is. So what will happen? This student will get one candy more than its right neighbor. The right neighbor have one, so this will get two candies. So total candies for each student after comparing for the right neighbor also, what will it be? 2, 1, and 2. Okay. Now let's calculate the total. Total candies would be, now first condition, second conditions, A part and B part, means both neighbors have condition have been satisfied. So now it's time to calculate the total number of candies, because these are going to be the minimum candies also. Okay. So 2 plus 1 plus 2 will become 5. Let's check the output. Yes, for the test case, it is 5. Okay. So till here, I hope you understood the process. Now let's move on to the pseudocode. In the pseudocode, here n was equals to 3, and now array is the array I have taken to store the candies. Okay, so please don't get confused. Now, step number one was what? The rule number one, to fill, to give each student at least one candy, correct? This was the rule number one. Each student must have at least one candy. So what will happen here is, fill this candies wala array 1 1 1. Rule number one satisfied. Rule one done. Okay. Now, rule number 2A for the left neighbor. How to do that? As I said, the leftmost student doesn't have any left neighbors. That's why we'll start from the second student. Okay, so that's why I equals to 1. So we'll be starting from here. I is here, 0, 1, and 2. Now, is the rating of I greater than rating of I minus 1? Rating of I is 0. And is 0 greater than 1? I minus 1 is 1. No. So what will happen? We'll reiterate. Then, because I plus plus, na, and then we'll reiterate. So now this student, last student, is a rating of I, which is 2, is strictly greater than I minus 1. Rating of I minus 1, which is 0. Yes, it is. So what will happen? As of I equals to as of I minus 1 plus 1. So left, as of I minus 1 is the candy that this the left neighbor have right now, which is 1. Then 1 plus 1 equals to 2. So that's why this part will become 2. And let me call these array instead of just candies. Okay, because in the pseudocode I have taken, so array, array, and array. Okay, so left part is done, and 1 1 2 is here. Now let's try to run it for the right part, right neighbor. Okay, right neighbor. So again, the last student doesn't have any right neighbor. Okay, that's why what would be doing? We'll start from the second last student. Okay, so again, our I would come here. Second last student is here. Our I will be starting from here. Now, if rating of I is greater than rating of I plus 1, okay. What is the rating of I? 0. Is it greater than rating of I plus 1, which is 2? No, it is not. So what will happen? Reiterate. So I minus minus, I would be here and then reiterated. So again, rating of I, which is 1, is it strictly greater than rating of I minus 1? So I plus 1? Rating of I plus 1? Yes, it is, because it is 0. So yeah. And this condition is just for the safe side, okay? Because if you already have, I mean, the student that you are checking for, if he already have candies more than its neighbor now, then we don't need to update it or add any candies, because in the question it is asked for minimum. Okay, so that's why just for the safe side this condition, and then as of I equals to as of I plus 1 plus 1. Okay, so then what would happen? As of I is this, as of I plus 1 plus 1, so 1 plus 1, it will become 2. So finally it will become 2 1 and 2. Okay, it will become 2 1 and 2. So after becoming 2 1 and 2, what would be happening? 2 and 2, we will be just counting it. Okay, so total sum, to take the sum, okay, in the count integer, count variable, 2 plus 1 plus 2 would become 5. Correct? That's what our output is, returning 5. Okay, now coming to the time complexity part. Okay, this took order of n, this also took order of n. Okay, so total time complexity would be big of n only. Even summing up also took order of n only. Okay, nothing more than that. And space complexity, because we used extra space to store candies. Okay, and what was the size of that array? Same as the input array, so order of n. Okay, so I hope you got it. That's all for this session. Thank you, everyone.